Moving. All right, so I'm going to show you another way to think about the union. And this is fine if you want to think about this way and solve for it this way, but this is generally, I think, not, I don't know, I don't think it like syncs up with our minds as much. It's a little bit more complicated, but I'll try to give you some intuition with a visualize behind why it works. So let's say, there we go. Let's say I've got this entire experimental outcome space, right? And let's say circle A is right here. And let's say circle B is right here. Okay? Now I'm going to break this down into 3 components. Okay? So the easiest, I think, that we've already talked about is what's in both of these events, right? Well, that's just the probability of A and B, right? I'm in both of those circles at the same time. So here, and I'm going to try to draw these so that if you don't have colors, it's okay. But some of the stuff we'll do in this class, it's like a lot of econ classes, colors sometimes help, right? But if you're taking notes, kind of try to draw the way I'm doing this. So let's think about where would B complement be? Well, B complement is everything that's not in circle B, right? So I could literally just take lines and kind of shade in the area that's outside of that circle B, okay? So this red kind of represents B complement. So if I want to think about what is this crescent moon kind of on this side? Well, that's everything that's in circle A and not in circle B, right? It's kind of where circle A overlaps with this shaded red area, which represents not being in B or B complement. So this kind of crescent moon over here is the probability that I'm in circle A and I'm not in circle B or in B complement, okay? Now let's think about where A complement would be. Well, that's everything that's not in circle A. So I'm going to draw vertical lines here that aren't in circle A. Okay? So you can think about as this blue shaded area would be A complement, right? So now I've got this crescent moon over here. I have kind of what's in both of them. And then I have this crescent moon that I still need to figure out what that is, right? Once I have this crescent moon, and kind of the intersection, I could just add those three parts up and I'd have the entire space that represented the union, right? I'm either in circle A or B. So this crescent moon is everything that's in circle B, but not, right? This blue area is not in circle C or A complement. Sorry, not in circle A or A complement, right? So this crescent moon over here represents I'm in circle B and I'm not in circle A or A complement. So if I'm thinking about, well, what does the area within either one of those circles represent? Well, that's what we were saying was the probability of A or B, right? I could be in anywhere in this space. Well, I could break that down into these 3 components. So if I add these 3 together, I should get the union. I'm going to try to do something here. It's a little, it worked last class, so hopefully I can reproduce it. What did I do? I went back. I'll change this. Here, I'll stop this share real quick. I'll get that back up on the screen in just a second. This is a little clunky, but I think it's worth taking a 15 seconds for, okay? So you guys can still see that. So I actually want to go now to share my screen. Oh, please work. I'll go ask him. I have to remember what I did. All right, the moment of truth. All right, I got it right on the first try. Awesome. So let's go back to when I told you you could make that L and just add up those components, right? So why did that work? Remember, we just broke it down, the union down to 3 components here. where's the probability of A and B complement? Probability of A and B complement, plus the probability of A and B, plus the probability of A and B, plus the probability of B and A complement. So that's why like making that L works, because it represents kind of each of those crescent moons and then whatever the intersection is. So, you know, I think this way is a little bit harder. I think it's probably easier to just take the probability of the two events, the totals there, and subtract out what you double counted the intersection. But this is another way of finding the same thing. And sure enough, right, when we add these three values up, we got that same answer of 0.7 for the union, okay? Any questions on that before we keep moving? Anyone on Zoom? Look at the chat here. We're good? Okay. All right. Now I'll try to do some more of this now that if I can remember the steps, so we can kind of have this whatever I had in the dot cam, so I don't have to just kind of like reference the slides. We can kind of see them at the same time. But for now,